Now, let's take a look at simulation for ST3. We'll start with one of the most important tasks associated with any simulation project, simplifying or defeaturing. The inherent ability is already part of ST3, so we'll leverage that functionality to facilitate our simulation workflow. We'll start by in-place activating into this spindle and turn off the display of the background components, hide previous level. I'll turn on the simplify mode, then modify and remove some of the faces I don't want to include in the analysis. This will allow us to simplify the model and shorten the time required to run the analysis without physically removing the features from the design model. I'll also remove some fillets by selecting the features that I also don't need to be part of the analysis. Now that I've prepped my model, I can go back to the assembly and continue with the analysis at the assembly level. You'll notice that the features are still there because I'm representing the model in this assembly as full featured. Let's change that by representing a simplified part. Now the analysis will use this version of the spindle. That's how easy defeaturing any component in the assembly can be. So now let's start the simulation process, and the first order of business is to define the geometry. The easiest way to do that is to select the geometry. The rest of the commands in the ribbon bar become active, allowing us to move through the process dynamically. We can reduce the need for many physical prototypes by providing a wide range of simulation features. ST3 adds loads like torque and bearing, as well as constraints like user-defined, building on the breadth and width of the tools already provided by previous versions. For this project, we want to define a force on this blade. If this blade is spinning at a high rate and it hits a rock, are the parts going to respond? Notice I can define the direction of the force using the solid edge steering wheel. The next thing I want to do is fix this plate. It basically represents the deck of the mower. It's actually a simplified piece of the deck. Next, we need to describe how these parts are connected to each other. Using the connectors collection, you'll see we have both automatic and manual connectors method. Let's use the automatic method. It's the easiest and quite a time saver. We then simply select the parts, in this case the 3 parts, and then tell the system that we want to glue them together. We receive the results dialog where we can select Create Connectors. You'll be provided with a visual description of those connectors that also gives you something to grab onto for editing. I'm going to turn off the graphic information for now to clean up the view a bit. The next thing I want to show is defining how the spindle and the plate are connected. And for that, we have a bolt connector in ST3. I can go around and select each one of the holes, but we also have a method select all holes on a plane. By selecting one hole, it goes across the plane and selects all holes that reside on that plane. It also selects all the pertinent information about the adjacent holes on the other parts. We also want to turn on the bolt spider, which will make a connection between this bottom face, the spindle, and the top face of the deck, and we'll put them in the same collector. And I'll also change the pre-stress force to 100. Once that's done, we're ready to mesh the parts. We select the mesh command, which will mesh the model. We also have tools for redefining the mesh along the edge, surfaces, or body. So we could change the mesh size of any of these edges, surfaces, or body at will. When that's done, we can run the results. You'll notice the feedback is very quick. Now, looking at the results of the spindle, you'll notice that the shaft is taking quite a hit. There's a lot of stress at this location. If we want to be more specific, we can use our probe tool. Turn on the show displacement. We can actually extract that information and see what the value of the deformation is at that specific node point. And we can place that information in the probe table, which can easily be copied to an Excel spreadsheet. Just another way to share this information with someone we're collaborating with. The workflow for simulation in ST3 is very straightforward. Leveraging built-in features in ST3 like Live Section, for example, allow us to modify the model or assembly without losing the setup of our simulation project. Live Section is a quick and easy method we can use to solve the basic problem of the shaft's lack of material by quickly manipulating the contents of that region. Once adjustments are made, we can simply rerun the results to see the impact of our adjustments. Provided in the Solid Edge Premium package, Simulation for Solid Edge is an easy but powerful tool provided to the engineer who's responsible for the integrity of the system design. On behalf of Acuity Solutions, I'm Anton Bullock, and thank you for spending some time with me and Simulation for Solid Edge ST3.